This video demonstrates how to use bold pretension in Ansys Workbench. Here are three parts: bracket, bolt, and nut. This assembly is given a bolt pretension load of 100 Newton and it is defined with frictional and bonded contact with suitable contact algorithms. Let us begin with the tutorial. Create a new static structural analysis. Rename the static structural analysis as bracket assembly. Under the engineering data, double-click on this. Make sure that the structural steel material is selected. Use the units as metric. Similarly, change the density unit as ton per millimeter cube and change the Young's modulus unit as MPa. Now add the bilinear isotropic hardening characteristic. Under bilinear isotropic hardening, change the unit of yield strength as MPa and the tangent modulus unit also as MPa. Enter the yield strength as 250 and the tangent modulus as 10% of Young's modulus. Once the material is defined, return to the project. Import the geometry, which is the assembly of bracket, bolt, and nut. Right-click on geometry, pick on Import. As bolt pretension assembly is already there in the temporary memory, I am going to use the same assembly file, which is in the step format. The step format is a neutral format exported from a CAD package. Pick on bolt pretension assembly. Observe the check mark here, which means the geometry is loaded. Now double-click on the geometry, which will open the design modeler. You can observe the message here. It will take a few minutes of time to open the Ansys design modeler. Confirm the unit in Ansys Workbench as millimeters. Click on OK. Under the import, observe that the solid bodies will be imported, surface bodies will be imported, and line bodies will not be imported. In this case, we want to import the line bodies too. We don't want to import the surface bodies. Now pick on Generate to refresh the geometry and to modify the import feature. Observe here, there are three parts made up of. One is nut, bolt and bracket. The remaining are the datum curves and the datum axis which were imported, or which are the curves or the axis of the CAD package file. Retain only the curves which are required. Remaining suppress. Check this curve. This is required. This is also required. The top curve is required and this curve also is required for splitting the top surface. Apart from that, whatever the datum curves are there, just suppress those. These are the datum axis. Right click, pick on suppress body. Now use tools, pick on face split. Select the surface under the target face. Make sure that the face icon is selected. This is the selection filter. Pick on the top surface and confirm by picking on apply the target face. Under tool geometry, use the curve or edge for splitting the surface. Pick on this edge, press hold Ctrl, pick on this edge, pick on apply. Now generate the model so that the splitting of the surface is generated. Observe here, under selection filter, pick on the faces, pick on this face and pick on this face. Observe that the face has been split into two different faces. Similarly, use the bottom curve to split the area, this whole area around the nut. Pick on tools, face split. Under the target face, pick on this top face, apply. Under tool geometry, ensure that edge is selected. Pick on this edge, press hold Ctrl, pick on this edge, pick on apply and press regenerate. Ensure that the datum surface, the face is been now split into two regions. The main objective of splitting the surface into two segments is that it is very easy to define the contact between the two bodies at their interface. Splitting the surface will reduce the number of contact elements and hence reduces the computation time. Once the face has been split, suppress the bodies which were used for splitting the surface. 1, 2, 3, 4. Right click, pick on suppress body. Observe, these are the edges. Now, save the file and proceed for the simulation. Open the project page, double-click on the model. Observe the message starting mechanical. Now the model is being imported into the simulation file. As it can be seen under geometry, nut, bolt and bracket. And these bodies are made up of steel. There exists one coordinate system, that is global coordinate system, which is located here. Y, X and Z are the axes for this default coordinate system. Now, the bolt will be given a pretension along its axis, which means the bolt need to be defined for its bolt pretension under its own axis. That is, a new coordinate system should be defined, which will be used to define the bolt pretension. In that case, always z-axis to be along the axis of the cylindrical body or the bolt. Pick on the coordinate system here. To create a coordinate system, pick on this geometry and pick on apply. A new coordinate system is created, but along the axis of the bolt, the axis is y. To change its orientation, pick on axis to be z, which is going to flip the z axis, or use defined by y axis. Now the axis will be z on the axis of y. Once the coordinate system is defined perfectly, rename the coordinate system as local. Now, under the connections, observe that there are three contacts: the contact between the bolt and the nut, contact between the nut and the bracket, and the contact between the bolt and the bracket. It has to be defined with three different contact types. The first contact type, that is the bolt and nut, should be a bonded contact. Its behavior to be symmetric, and use the formulation for the bonded contact as pure penalty. Now, change the detection method to on Gauss points. Once these parameters are defined, proceed for the next contact region, that is this region, the contact interface between the nut and the bracket. This contact has to be a frictional contact. Pick on frictional, enter the coefficient of friction, generally 0.15, and choose the behavior to be symmetric. Under the formulation, use the augmented Lagrange formulation and use the detection method to be on Gauss point. Choose the interface treatment to add offset ramped effects. The load will be applied gradually. Similarly, pick on the third contact region. Change the contact type between the bolt and the bracket to be frictional and its coefficient of friction to be 0.15, the behavior to be symmetric, and its formulation to be augmented Lagrange. Use the detection method as on Gauss point. Similarly, interface treatment to be add offset ramped effect. Once the contact definition is complete, confirm whatever the parameter defined for the contact interface. The first contact is the bonded, the behavior is symmetric, formulation is pure penalty, detection method is Gauss point. Once all the three contacts are ensured, right-click on the connection, pick on Insert, use Contact tool. Under the Contact tool, right-click, Generate Initial Contact Results. This will evaluate the initial contact status. Under the Contact tool, pick on the initial information, which says there is no issue in the contact. All the contacts are closed. There exist 3 contacts between 6 faces. Now proceed for the structural analysis. Make sure that the mesh is automatically generated. To add the refinement of the mesh to detect the proper contact at the areas, refine the mesh. Right-click on the mesh, pick on Insert, use Refinement. Under Refinement, select the faces where it has to be refined. These are the 2 faces now selected, highlighted in green for the refinement of the mesh. Pick on Apply. Now pick on Generate. The mesh will be refined locally in the areas. One more thing we need to ensure here is the contact and the target bodies. Pick on the contact region. Observe that the contact has been taken between the nut and bolt. The blue highlighted body is the target and the red highlighted body is the contact, that is the nut. Now pick on Structural, right-click, Insert, use the Fixed Support. Under Fixed Support, use the backside face to rigidly fix. Pick on Apply. Now apply the bolt pretension. Right-click on the structural, pick on Insert, use bolt pretension. Use the cylindrical surface over here, which will automatically detect the bodies, confirm the selection, and enter the preload as 100 Newton. Observe the bolt pretension symbol. Now check for the required results under Solution. Insert, Stress, Equivalent or von Mises stress. Always use the strain, that is the plastic strain, equivalent plastic strain, to know any permanent deformation or the failure. Right-click on the solution, pick on Insert, pick on the deformation, the directional deformation. The directional deformation to be in z-axis with respect to the local coordinate system which is defined. Once all the static structural analysis parameters are defined, pick on Solution or Evaluate Results or Solve the problem. Right-click, pick on Solve. Observe here the solution status. To plot the convergence, pick on the solution information. Under the solution output, use the convergence of force. This is how the force will be converged. It will take some time. Remember, in this problem, we have not used the time stepping options. This problem is being solved by the automatic time stepping. When the problem fails to solve, use or increase the time steps so that the loading will be very gradual and slow, which will help the problem to converge faster. It can be observed from the convergence plot is that the force convergence and the force criterion are now converged at this area, and this is the cumulative iteration. Once the problem is converged, this is the exact solution to a problem. Pick on the equivalent stress, pick on the equivalent plastic strain, and pick on the directional deformation. Use animate results for animating the equivalent stress. Pick on animate button. This is how the object or an assembly will behave when it is being tightened with the nut. To plot the deformation in other window, pick on switch windows here, that is to viewport. Under the second viewport, use the directional deformation. Observe the magnitude of deformation here. Pick on this window, animate the result, and close the windows for the better visualization. Thank you for watching this video. Please subscribe my channel, and for more videos visit the playlist in my channel.